tutti. Hello, everyone. I'm Matteo.
And I'm Konstantin.
We...
Thank you so much.
That was easy.
I mean, I didn't expect it, but I like it. So if you want to do it during the presentation even more, I'm here. I can say my name again and again, so it's not a problem.
So we are part of Shiny Frog, and we like to make app for the Apple ecosystem. We are the maker of Bear, which is a note-taking application for macOS and iOS. But today, we are here to reveal the sacred secret behind our app speed.
So yeah, when we got invited to speak here at Pragma to do our talk, we made the homework. So we made the research, and we learned that there are two golden rules. Rule number one, only one speaker. Rule number two, never, ever touch sensitive topics.
But we like challenges.
We do. So what do we learn during our 20 past year of working together? One of the things is what we like to call the faith-driven development. Many of the issues inside Bear were fixed thanks to the people of faith. Those people are very eager to share their use cases. They are very generous in providing their database for testing, and they tend to write really, really, really long emails. I mean, yeah, that's right. So actually, the real name of this talk should have been this: what would Jesus cache? We told Klaus that it was better, but yeah, it was censored. So as you saw, as you understood already, we are silly people. So we didn't want to come here and just flip slides. We wanted to add drama. So we decided to present it as a double-featured B-movie. So I will leave it to Matteo to start since the beginning.
Thank you, Konstantin. So for starting from the beginning, we need to time travel a little bit to 2013. At the time, I was just a young lad full of hope. You can see, at the time, I was like 30. And we already shipped some application with the team. And we made like various applications, but I had a dream. I wanted to build a note-taking app. So the first thing you do when you build something, you need to estimate how much work you want to put in it, right? So I said, we have some experience, we know how to do the job, so let's say it would take about 1 month of work, right? But we developers, we're smart. So I double it, and double it again. So that makes about 4 months, tops. So anyway, according to the master plan, 3 years later, we finally managed to ship the app. And it was amazing. The app was beautiful. Our users were very happy to use it. 5-star review were flocking in. It was bliss. So we thought ourselves, we are done. We don't ever need to do anything else. But we were naive, because destiny, or something more mysterious, had other plans for us. And that brings us to chapter 1, the Dutch pastor. So we were still basking in the glory of the release. The team was happy, I was happy, but an email came in from the Dutch pastor. And he says something on the line of, guys, I really like Bear. It helped me study the Bible like no one app does. But I have a really small problem. After a year of usage, the app is now taking several seconds to load. Several seconds to load. For any developer, this is a very jarring phrase. I mean, no one wants their app to take several seconds to launch. And we were really puzzled about that because we had everything. We had like unit test, performance test, integration test. We tested the app with a database of 10,000 nodes and hundreds of tags. It didn't make sense. So we did the only thing that a developer can do at the time. It's not us, it's you. That's the only explanation, right? But that man, that legend, came back again, and he said, I'm willing to explain in excruciating details how I'm using Bear day by day. And he said something like, when I study the Bible, I create a new note for every paragraph in it, and I tag it with the character and the location so I can reference it later. Now, I never read the Bible, but it's not a small book. So we were a little bit afraid to ask more information, but we had to. So we asked, I'm sorry, how many nodes do you have inside Bear? And he said, oh, not too many. I just have 90,000 nodes and around 20,000 tags. And so this was me at the time. But at the same time, I had a revelation. It's just a madman. It's a niche case. No, it's not a niche case. Actually, it is the niche case. Something we can safely ignore. No one else in the world should have that problem, right? But you know, as a developer, you get that itch, that urge. You know that there is a problem there, and you can't sleep at night. So with the team, we decided we need to fix that problem. For that poor man, I mean, he can wait several seconds each time you open the app. But we need to understand why. Just that alone can be the problem. I mean, we are using a SQL database, and we didn't know how to proceed. So we asked for more information. And he said, let me show you my Bear. And then he showed us his sidebar. Now, I will start a video, and it's going to be long, so please sit tight. On the left, you can see the sidebar with the tags of the user. And now let's start scrolling it. I will take a small break. Still going. Still going, still going. Nearly done. Almost there. And there we go. So that's a sidebar. Now, we had more information, but we still needed to pin what the issue was. So what is a sidebar? At least the sidebar in Bear is just a tree. And we as developer, we know tree, right? We traverse them, we sort them, we flatten them. We basically dream in trees. And we did everything we could, everything standard. We had stable IDs, we had parent pointer, we had ordered array of children. When we created the sidebar of Bear, we did everything by the book. And we went also the extra mile. We made sure that the children were lazily loaded. Wait, what? Lazy loading, you said? Well, that smells kind of like pre-optimization of something that isn't really a problem. And that actually was the problem, because if you're a pastor with 12,000 tags, and then you keep them open all the time, when the app starts, you need to query for each tag to get the subtree, and the database get it again and again and again. And that's adds up really quickly. And then it came the miracle. Or as we call it inside the fix for the problem. So we switched the code to be a single query to get all the tags of the user. We built the tree in memory, and the speed was back. The code was simpler now and more manageable. And it wasn't just for the pastor. Actually, we managed to get the average launch time of the app to like half a second for everyone else. So it was truly a miracle. You can clap now. But now we change everything, and I leave you to the intermission.
We could go on and on forever. Like, I think that video was 10 minutes or stuff. But if you want to, after the talk, you can talk to me. I will show it to you in here in its entirety. So with Matteo, we left Bear very fast. I mean, really, really fast.
That's farting, it's not fast.
No, that's fast. That's fast. So at that point, we had no more problems, right? Wrong. Welcome to the chapter 2, the Iowa pastor. So, once again, we were happy. Everything worked fine until an email came. And the email was from the Iowa pastor. And those are very, very long emails, as I said before. So he was telling us that Bear was slow, especially in the search inside the editor. And that was impossible, because no, it was impossible. So because we tested Bear like with the entirety, like the full book of Moby Dick inside OneNote, or Alice in Wonderland, because those are copyright-free. So we have notes with the entirety of the books, and we test the search with that as well. So the pastor said, yes, but I use Bear to keep track of the sermons. So what we imagined was this. So as a normal person would do, you just keep one sermon inside one note. But he said, no, I am keeping everything in one note. I mean, why do you need to waste the notes, right? So he just appended each sermon, each week, inside one single note. So at this point, it was kind of a leap of faith. We were tested, so we did what we do, whatever we are tested. We tested the app. And he kindly provided us with a note, with a full note full of sermons. And unfortunately, after trying it, the user was right. And anger came, and came denial again. And when you are angry, you are being tempted. So it was like, it's just one user. Nobody else is complaining about this. And actually, it's statistically irrelevant, right? But again, we started to breathe. We cooled down. And we said, OK, yeah, probably investigating this case could make Bear better for everybody. And spoiler alert, it did. Now you would say, OK, Konstantin, you are just making the slides up because what does this image, why does it represent the spoiler? But you have to know that this is a very interesting painting from a Dutch painter of the 14th century, I think, something like this. And actually, it does have a spoiler. So inside the Nativity of Christ, we have the same Christ at the end of his career. So I guess this applause goes to Roger van der Weyden that made the painting. It's not mine. And it's not AI as well. So, I mean, it's just amazing. So, in order to better understand the problem, we have to understand how the search works. So let's start simple. How does a normal search inside the string work? So we have a string, we take it, we just perform an algorithm, whatever algorithm you choose to get the results. You have the ranges of the results inside the string, you store those ranges, and then profit. Usually, in this case, the profit is using the results. So, for example, highlighting them inside the string. Now, unfortunately, in Bear, it's a little bit more complex. As we told you before, Bear is a note-taking app based on Markdown. And I would like to show you an example on what's going on inside Bear. So let's take, for example, a table. Markdown has a support for tables, and this is the representation of the table inside Markdown. But in Bear, you would see something little more pleasing to the eye. So this is the same table, but inside Bear. But this is a lie. If you analyze, like if you see the view structure inside Xcode, you would see something like this. So it is a separate controller that presents the information with one big image. So that text doesn't exist, right, inside there. The only existing text is the one of the edited cell. So the cell that is being edited is a real text view. And we have like a lot of elements like this. So we saw the table, and the table has the text inside Markdown and has the text also visible to the user. But then, for example, we have the images OCR. So the text is inside the image. It's not inside the text of the node, but it is visible to the user, right? Then we have the possibility to fold text inside your nodes. Here, you have the text inside the Markdown, but it's not visible to the user. And all these cases, in all the cases, what we have back from each client, so the tables, the images, or the folded text, is a search result. The search result, this is a very simple, just to give you an idea, but it's represented by a client that is a reference to the client that has generated the search result. In our case, the editor, the table, images, and you go on. And then a dictionary of client ranges, where any hashable, the key of the dictionary, is a reference to the client, and then the range associated with the client for that result. And you would say, OK, Konstantin, but why don't you just have a range? I mean, a range should be enough, being that you know the client. Unfortunately, it's not so easy, because, for example, those are different search results that you can have inside there. And as we saw before, the table has search results inside, and the table attachment, the client, knows how to represent them, how to highlight them. Then we have the image. The image knows as well, the image attachment, how to represent the highlighting of the result, but the folding doesn't. So in this case, we had to delegate the highlighting to the editor, and we had to have two ranges, one for the client that generated it, the folded text, the other for the editor. Now, if we want to, coming back to the pastor, so if we want to debug his situation, where would we start? So we started thinking, and we said, like, OK, it's a search. So probably the problem is in caching. We don't cache search results. So every time we need to get to them, the search is being made again, again, and again. And of course, this builds up time. But unfortunately, we checked the code, and we already cached. So our past cells did a good job, and there was caching. Everything worked as it was expected. So we were even more confused. And at this point, I will just say that, in my humble opinion, from now on starts the actual interesting part of my part of the presentation. So you can forget everything I said before, because it's very app-specific, but what I'm going to say from now on applies to whatever app you make. So it can help you speed up the slow parts of your app. So what did we do? We said, OK, difficult problems require difficult solutions, maybe. So we said, OK, it's time for profiling. I don't know if you ever used instruments. I usually don't use instruments because I'm a bad programmer. But in this case, it was very necessary. So you just start product, profile, and instrument starts. Then you choose the time profiler, and you will see the actual time profiling instrument. So at this point, you press the record button, and it will start recording what you are making inside your app. So now you will just perform the slow tasks that you are trying to debug, trying to understand what's going on. So in our case, we just perform the search again, and again, just deleting one character and adding it again. Instruments records what is called the time profiler row, and there you will see like spikes for all the operations that are very heavy on the CPU. And that was what we looked for. And on the second line, you also will see the hangs, and that's a very clever way to blame the developer, because when you see like hangs, you're just starting to get nervous. So in this case, the hangs are blue, because those are micro hangs. Because before making the screenshot of this situation, we already have fixed the major issues that we had, because there were other issues. But one of them was very interesting, and that was the last one that we found. So once you have collected your data, you select a part of the chart that you are interested in, so the one with the hangs. And on the right side, on the right bottom side, you will find what instrument thinks could be the problems, where in your code the problems could be. And we saw Swift dynamic cast. And that was not a function we were calling. That was not a function that we would expect to be called during a search. And the worst part of this was that actually it was taking 30% of the search. So every time a search happened, this phantomatic dynamic cast took 30% of it. So we investigated a bit more, and everything came back to the result that we saw before, and especially to the any-hashable. So in this case, we understood in the bad way that any-hashable is a type-erased hashed value. Now, we could not use the protocol that we usually define the clients in, because you cannot use protocols as keys of dictionaries. So we use the any-hashable that seems to be perfect for the case. But being a type-erased hashable value, it meant that every time we put client as a key, his type was erased. It was cast into a type-erased hashed value. And every time we need to access it again, so during iterations, we wanted to have back the original type, it needed to be cast again. And this casting happened back and forth. So, for example, in this case, using instruments, the fix was very easy. We just stored the UUID, so a concrete type for the clients, and we added a dictionary of clients just to have the reference back for later iterations. So in this case, we trusted Swift, and we were betrayed. But actually, this is what we like to think, because it's the shame that talks in this way. Actually, what really happened was read the effing manuals. So please, Matteo, tell us, what did we learn today?
So what we learned? We learned that by fixing some edge cases, we managed to make the app faster for everyone, so that was a win. Sometimes the code was made simpler and more manageable. And we got a reminder that doing pre-optimization is dangerous. But don't worry, we keep doing that. The most important thing that we learned, actually, was that you have to understand that even if you don't believe in something, that something could still affect you, your app, or other user. So don't be so quick to dismiss those niche cases, because that could make the life better for you and for your users. And that's the secret behind our app speed. Thank you.
Thank you, Peter.
Thank you. I was pleasantly surprised about your theatrical capacities or whatever it's called. Yeah. Questions? Anybody has question? I'm coming. I'm arriving. Arcadius? Oh, okay, cool. Any religion question is also allowed.
Hello. So I've tried to use Bear a few years ago with limited success because I didn't have time then. But my question is about searching. Did you try to implement search with something like SQLite or just delegate searching to some more lower level mechanism? Or you don't use the database for some other reasons?
I feel like this is a two-part answer. So there are different kinds of search in Bear. One is the generic search that searches all the nodes, and that's done via SQLite, and that filters the nodes. And the other one is inside the editor and just search the current text that is present there. So what Konstantin talking about was the editor part. So in that case, we just have the in-memory representation of the text plus all our view controllers that represent other types.
Yeah, it could be, just to add something, it could be possible going lower level, but you would have to recreate the structures that we have. So just for readability, for simplicity for the future, for our future self, because we plan to give us other medals, we kept it high level in this case.
I understand. Because my main consideration is how much would going lower level increase the speed? Would it be a lot of increase in your case, or you think that it wouldn't be worth a hassle?
I think it depends on which client you're talking about. For example, like images, we are using like the OCR engine for Vision Kit. And in that case, it won't really matter because that async takes a little bit of time to get back the result. So even if we go lower level for the string, that doesn't really add up too much. And also, searching for string is super fast. Computers are very fast right now. So just the string is almost instant, even if you like search the Bible. The problem are the other searches, like OCR or maybe table, because we have all the view hierarchy that we need to account for, and things like that.
I understand. All right. Thank you.
Thank you.
Just behind you. Just behind you.
Thanks for an amazing talk. Giving a talk with 2 people or more is not easy, and this was amazing.
Yeah, because they cost double.
Yeah,
that's the problem, yeah.
It was so fun to watch.
Know.
You absolutely did amazing. Now, I was wondering, there were 2 Dutch references with the Dutch Pope and the Dutch painter. What is your relationship to the Netherlands? Because I love the Netherlands.
Actually, I would say we have no reference to the Netherlands. I mean, I lived there for 5 to 7 years. I don't know because my memory is shit. And but actually, the pastor was Dutch. He was a Dutch pastor that was studying Bible in Netherlands. And the painting was just because you don't find other painting with spoilers and religious reference. So it was just the only one available. Fortunately, they made it.
Amazing, I learned something new.
So we love Netherlands just for that, yeah.
Nice, thank you.
Also, he's a madman, right? So,
yeah.
Absolutely.
So we have time in front, yeah.
You mentioned that for tables in Markdown, you basically cache them as images. Can you elaborate why you do that? Because it seems that could be quite inefficient for very many tables, like involving image data, all these pixels that you have to hold in memory and so on.
Let me get that.
Hate you.
So we tried everything, and I mean everything. So the basic problem with the text view is you don't really have a real viewport, because the content of the text view is, you have the viewport of the text view, but the other things doesn't have a scroll view. So you know how much you are displaying. So like in the case of tables, we know what's on the screen. But if you have like a big table with a lot of cells, just having views and trying to resize the text view or try to relay out everything is super slow. While if you just have an image pre-rendered and you render just the part that is visible right now in the text view, is super fast. You can't beat that.
So essentially, you don't hold those images in memory, but just calculate them on the fly when it's actually shown.
Yeah.
Makes sense.
And also, like, this is a very interesting, like, the tables are a very interesting case because dealing with an image, every time you interact with the table, you don't want to have the double click in order to have your selector, right? For example, if you want to double tap on a word, you want that word to be selected. And fortunately, iOS provides you the hit test function, so you are able to create the text view underneath before every gesture recognizer starts. So actually, we really tried everything, and that was the only possible way.
We cheat.
We cheat, yeah. And also, like, in this way, we have only one text view on macOS for table. But on iOS, you can have multiple of them, because if you start to scrolling with 2 fingers, 2 views will be generated. So it's a very, very, very interesting topic. So, by the way, yeah. I'm sorry.
No worries. Next question.
So guys, when you identify those cases, afterwards, did you set up any code or logging or stuff like that to measure some critical places in the app to identify, to measure the impact that you have? Because you have one priest now, but maybe you have a lot of hidden ones in the basement. So do you use something like that at critical places? Do you measure uncertainty somewhere in the app?
The answer is no.
The answer is it depends.
And there is, I mean, as developers, we have our measuring tool. We have tests that measure speed and things like that. But there, we pride ourselves to be a 100% private app. So we have literally zero analytics from the users. We don't have any idea how our users are using the app. We don't track anything. Basically that's it, privacy.
You wait for emails.
We wait for emails.
We wait for emails, yeah. If you can
We just refresh the email client every half an hour.
wait for email from pastors.
Absolutely. Those are the best. I mean, I would like to thank here publicly every pastor in the world, because they are very good people. They really provide you with the examples and really try to solve the problems with you. All the other users are not that pleasant.
While you pass the mic to your right, because Emad has a question.
Thank you for the talk. I've been using your app for years, and I really enjoyed the export capability. But when you mention about the table that being exported as transferred as an image, but you're not using that image when you're exporting the file, right?
No. We are redrawing everything. Like, for example, if you export to PDF, we are drawing the image in the PDF, so you get like a vector representation of it. Okay. So you get like the best of both worlds.
Yeah. Cool.
Yeah, because every node, like what you see in the editor, is a high-level processing of an AST. So the node is actually an AST, and we build the editor on top of it. So there are a lot of tricks, like the table is just one of those. But when like the exporting happens, we start from the real original data.
Okay. Thank you.
Okay, that's it. But you know what's funny? Right now, there is a... So come to them later for the next question, right? Yeah, because we have to go further. What's funny is right now there is a talk starting from Apple, but stay in the room because something even more nice is coming. And the talk is called Optimize Your App Speed and Efficiency.
Nice.
I kid you not. Right now there is a webinar from Apple starting now. But so give them a round of applause first of all.